This video is going to talk about games in normal form and specifically how we're going to get about looking to find the best response, how players are going to best respond to other players in a normal form game. A normal form game is another term for this game matrix. It's we take a strategic situation and we can represent the strategic situation using this matrix or box. You construct a box because this is a two-player game, and usually just the convention is always the player here with the rows, that's player one, and then this is going to be player two. And you construct a box because in whatever the situation that you're modeling, you decide what different actions or that player one can choose. And you create one row of the matrix for each option that player one can choose in the game. For each action or option that player two has available in the game, you create one column in the matrix. So with a 3x3 matrix here in this case, this would be a case where player one has three different options and player two would have three different options. If you want player two to have five options, then you could have a 3x5 matrix. So you can make the matrix as big as it sort of needs to represent the different actions that each player can choose. Now, when you get a matrix like this, and you're trying to figure out like how is it that what's the game theoretic or strategic element of this? Is that the way to think about it is player one gets to choose the row of the matrix, player two gets to choose the column of the matrix. Neither player gets to choose on their own which cell in the matrix they want to be in. They're going to make their choices. We'll assume they're making their choices simultaneously. And player one only gets to choose the row, player two gets to choose the column, and you combine their choices together, and then that would determine what cell in the matrix we get in. Each cell in the matrix corresponds to a possible outcome of the game. So we have this here. So the way to think about it, when player one is choosing their strategy, they're choosing which row of the matrix we're going to end up in. Player two is choosing the column. The first number in each cell, which I've written in blue here, would be player one's payoff. And that's, again, the convention we always follow. The first number in the cell is the player one's payoff. Remember, player one is the row player. Sometimes use this convention. One is this side, two is the column player, and then the second number is the column player. Now, the key to trying to figure out strategically how players will want to play this game is we use this idea of a best response. And so in trying to think through the challenge or the problem that a player faces here, we'll say is let each player proceed as follows. You do this mental calculation, this mental thinking through and say, if the other player does X, what do I want to do in response? So, for instance, we can look at here and say, player one could approach this by saying, if, and this is hypothetical, but we say, if player two chooses left, what would I want to do in response? If for some reason you knew that. So, like, for instance, the other, it's like football, and the other team is called to play, but they were calling into the quarterback, and then the quarterback tells the offensive players in the huddle what the play is going to be. If you'd listened in on that and you knew what play were the offense was running, what defense would you want to call? Right. So is this kind of thought? So if player two was going to choose left, then we ask ourselves, what would player one want to do? And to do this, then, what we can, one way to sort of visualize this, I could erase everything here, but another way of thinking about this is, I'll come over here and rewrite left, and just really reconstruct this this column of the matrix, and I'll just use up, middle, and down the initials here. And the only thing I'm going to write is, because we're talking about player one making this choice, I'm just going to write the payoff for player one in the cell here. So what we can see here is that if player 2 is going to choose left, player 1's facing a choice between if they choose up, they'll get a payoff of 4, middle, they get a payoff of 2, and down, they get a payoff of 6. Well, the best response is simply choose whichever strategy or action that player 1 has available that's going to give them the highest payoff. And the game theory ends up being really, in this case here in the matrix, is really quite simple. All you have to do is compare numbers. And you see, well, which one's the biggest number? And we see that 6 here is the biggest number. So if player 1 knew they were playing against a player 2 who had chosen left, then what we could say is that player 1 would choose down. Now, one convenient way of representing this in the matrix is through the method of underlining that they talk about in the book. So what you do in this case is when you've figured out when player 2 is going to choose left, player 1 wants to respond with down, what you can do is underline that payment, that number. What that's telling you is, again, against left, player 1 wants to choose 6, so it's to choose the payoff of 6, which they would get from choosing down. So that's how we could represent player 1's best response to player 2's choice of left. Now, of course, that was hypothetical, and we're doing this as a way to try and reason through what might possibly happen in the game. So it's possible that player 2 would choose center. If player 2 chose center, then, and somehow player 1 knew this, to think about their best response to center, they'd be like, okay, now they're in this column of the matrix, and the player 1's payoffs are the first numbers, so you'd be comparing these numbers here, and we see that 3 versus 4 versus 0, 4 is the highest payoff, and so 4 would be player 1's highest payoff in response to center. Underline the 4 here, and that's telling us that middle would be player 1's best response to center. And then finally, if player 2 chose right, player 1 would know they're going to be in the third column of this matrix. Their payoffs here are 7, 1, and 2, and 7 is the highest. That comes from up. So we know that if player 2 was going to choose right, player 1 would want to choose up. And so that's how you go about doing it. Now, well, I'll just do a 1 for player 2 because just to sort of see, you see the difference when you're looking at player 2. So, for instance, if player 2 knew that player 1 was going to choose up, then player 2 knows that they're now in the first row of the matrix. So in choosing what strategy they would want to respond to up with, player 2 is choosing between left, center, and right, the different columns of the matrix, or these different cells in this row. Player 2's payoff is the second number, the one in green here, and player 2 would be choosing between 3, 5, and 1. They could get 3 if they chose left in response to up. They would get 5 if they chose center in response to up, and 1 if they choose right in response to up. Player 2 is going to, the idea of best responding is simply to choose the action that's going to give you the highest payoff, and that would be here. And so it would be center, and by underlining 5 in this, it would be saying like player 2's best response to up would be to choose center. It's possible, you can definitely have a possibility in a matrix. You might have a tie. And if you have a tie, then we would say that both of those strategies would be best response. One isn't better than the other. So if there's a tie, then you'd be underlining 2 different numbers in that, and that would be showing that there's 2 possible best responses for a player to a move by another player. Don't worry if the numbers are negative. Remember that these are utility payoffs that we're using in this case. And your utility payoffs, if you think back to chapter 2, just the way we talked about utility payoffs in chapter 2, all that utility number is telling us is a bigger number represents a more preferred outcome. There's no reason we couldn't have negative numbers here. So, player one might have -4, -2, -6, and then in which case you'd simply be choosing between the you're trying to choose the highest payoff. If these are all negatives, then it would be middle would give them the highest payoff because -2 is bigger than -2 or -4 or -6. Again, if you have negative numbers in there, it's not a problem. Again, you're simply choosing, you're just comparing here to see which is the biggest number, and that's how you get best response. Now, we've done something kind of arbitrary here in approaching best response, say like, oh, well, if player one knows player two is going to choose left, but in a simultaneous move game, we say like, well, that doesn't really make sense because if it's simultaneous, then how does player one know what player two is going to choose? Well, we're proceeding with best responses here simply as a way to try to think through what's going on. And in the next video, we'll talk about how we use best responses then to come up with Nash equilibrium, which is how we might propose that players would play this game.